In 1992, Dr. Eugene Podkletnov discovered an anomalous gravitational effect while working at a superconductor research laboratory at the University of Tampere in Finland. This effect has since been replicated by NASA and ESA, the European Space Agency. But despite all this, the effect has been almost completely ignored by mainstream science. Francis Slakey of Georgetown University even going as far as telling NASA's Advanced Concepts Office that it was, quote, wasting money that could be spent in other more legitimate areas of scientific research. Boy, was he wrong. Frank Znardzik, who's an electrical engineer and physics hobbyist, was also in the laboratory at Marshall Space Center when the experiments were performed. The key piece of the puzzle that was missing from David Noever's earlier attempts was finding the proper stimulation frequency. Frank was the first to notice that when you multiplied this frequency by the dimension of the disk, you get a velocity which is approximately 1 over 137 times the speed of light. This yielded a new physical interpretation of the fine structure constant as a ratio between the speed of light in a vacuum and the speed of light upon entering the electronic structure of an atom. After struggling with equations in quantum physics for the past 10 years, Frank finally decided to publish his discoveries. The emergence of this velocity has since solved many long-standing mysteries in quantum physics, such as why the frequency of the emitted photon does not match that of any atomic state. This velocity can also be used to produce Planck's constant, and reveals information about physical systems which are fundamental to Planck's constant, such as Einstein's photoelectric effect, which we get from modeling the atom as a capacitor, as well as the radii of all atomic elements and their corresponding intensities of spectral emissions. When a photon enters an atom, it slows down to this velocity. This velocity is proportional to frequency times wavelength. The product of the wavelength and the frequency yield the transitional quantum velocity, which can be used to produce the associated radii through a relation involving a rearrangement of the Coulomb constant into the form of a spring constant, since the electrons are bound to the atom much like a spring. The frequency matches that of the emitted photon, while the wavelength in association with the configuration of an electric charge gives the energy of the photon. During the phase transition between electron states, the fields which bind the atom to each parent state must be released in order to reconfigure into the daughter state. During this quantum transitional phase, the electron travels at a specific velocity. This velocity is the same for all atoms, although the dimensions and frequencies change according to the change in density between the different nuclei. When Richard Feynman graduated from Princeton with his PhD in physics, his father asked him, "How does an atom emit a photon? Where does the photon come from?" Even Feynman at the time did not have a good answer for this. When an atom drops energy states, that energy is released in the form of a light wave, photon, or a lattice vibration, phonon, which is kind of like a sound wave. When a photon is absorbed by an atom, the speed of the photon slows down, much like the speed of light slows down upon entering a Bose condensate, which behaves essentially like a giant atom. The photon, or speed of light, slows down to the speed of the optical phonons, or sound waves inside the atom, and the energy from the photon is luminosonically transferred to the electron, which jumps up in energy state. It is during this phase transition that both speeds become equal and an impedance matching takes place between light and sound, but not like the sound you hear. These are called optical phonons, which bind the condensate which forms on the surface of atoms, due to the coulombic force of the atom balancing with the capacitance of the known universe. The opposite is true when the electron jumps back down to a lower energy state. It proceeds at the velocity of the quantum transition and a photon is released, with a frequency and intensity which can be calculated using this transitional velocity. The actual photon is emitted when the nuclear fields escape as the topology reconfigures itself to the new orbit. The amount of nuclear force fields which escape is exactly proportional to the radiation pressure of the emitted photon wave packet. The opposite is true for photon absorption, although it is important to note, since the wave is emitted or absorbed in the opposite direction that the electron travels, there is a Doppler-shifted reflection. This Doppler-shifted reflection of the electron or Compton wave has been the source of much confusion in physics, including the interpretation that light is both a particle and a wave. We now know that light is purely a wave, and that de Broglie's matter wave is simply the result of the Compton wave of the electron and its Doppler-shifted component. Planck's quantized units of angular momentum derive from a simpler velocity, which is that of the quantum transition, the missing step where the Compton wave and the light wave interact, and light is emitted and absorbed by atoms. This discovery has clarified one of the greatest misunderstandings in scientific history. Until now, the mathematical treatment of such quantum systems has relied on abstract mathematical notations, which amount to backwards attempts at explaining the experimental observables rather than understanding the actual phenomena which is producing them. Check the links in the description below for more information. There's a lot more theory and detail I will get into in future videos. The focus of this segment, however, is on exposing a revolution in advanced space propulsion. Future videos will go into other technological applications of the theory as well. So here's how it's done. By sonically vibrating an atom at the proper dimensional frequency, one can induce an artificial state of quantum transition. Through this process, energy can be pumped into the atoms and effectively transformed into gravitational propulsion, as the gravitational fields which bind the nucleus slip out of alignment and are forced to escape. In order to get a large propulsion effect out of this, you need a lot of atoms, and you need to get them to work together as a single atom. The way to do this is by using superconductors, which is why superconductor research scientist Dr. Eugene Podkletnov discovered the effect in the first place. Rotating the disk made the effect stronger, since the angular momentum would align the spin states in the atoms, making the effect uniform and directional. The stimulation frequency varies with the diameter of the disk, but as long as you follow these formulas, you should be able to replicate the effect on your own. Superconductor ceramics are fragile, and large diameter ones are difficult and expensive to produce, so in order to build a craft which operates on these principles, we would probably need to use a superfluid or some form of plasma. Earlier reports of a gravitational shielding effect defy conservation laws and are therefore false. However, the theoretical construct outlined in this video does not violate the laws of conservation. It's simply high-frequency electromagnetic energy in, gravitational propulsion out. In addition to NASA and ESA replications, Boeing Aerospace has been researching this effect in its highly classified Project GRASP. But aside from all this, let's stay focused on the scientific method. The real burden of proof rests on experiment. Modern physics has been taught to think inside of a box that was created back in the 1930s. This box may or may not contain Schrödinger's cat, if you understand that analogy. However necessary this eigenvector matrix wave operator formalism was to explain the workings of the atom from an outside perspective, it never noticed that this fine structure constant was a ratio of velocities. And by rearranging their equations in terms of velocities, it not only gets right answers, but it solves the confusion of meshing relativity with quantum mechanics. You can read that paper in the description as well. Both the Schrödinger and Dirac equations are dot products in function space. This function space lies across a threshold where the speed of light changes and merges with the electron Compton wave and its Doppler shifted component. Both formalisms attempt to calculate these things in terms of energy, using total energy operators known as Hamiltonians. This is a useful, but completely backwards attempt at understanding what nature is actually doing. Compare it to mathematically modeling a fractal without the original generation code. Every college campus with a physics lab also has a media lab where students can rent out cameras. If you're a student or a professor, go perform an experiment, or record yourself going over the theory and post your video as a response. High school algebra students should be able to comprehend the math involved. No calculus required. I've included a link to the original paper in the description. If the theory proves correct, it means that quantum theory can be taught at the high school level. It will also be the coolest thing that NASA's done in 30 years. The quantum transition has been revealed, the path has been shown. Please share this video as well as copy and save it to your computer. Everyone out there has me, the alien scientist's permission to copy and re-upload this video as long as they post a link back to my YouTube channel and website. Thanks for watching. May the Force be with you.